The use of chemical fertilizers in the Chesapeake watershed has soared in recent decades, as the number of people living and working here has tripled. From just about everywhere, chemicals called nutrients are being washed unnoticed into streams and rivers and carried to the bay. The result, here and elsewhere, is something called dead zones. Places where species that can't run away fast enough die for lack of oxygen. Over 300 persistent or seasonal dead zones have formed worldwide, and the number is growing. Throughout the region, solutions to the nutrient runoff problem are being tested, like incentives for farmers to change the layout of their fields so less runoff gets into streams, like restoring wetlands, which act as filters, like installing rooftop gardens and vegetation to reduce runoff from urban areas. Creative new solutions abound. For a young albatross, the first year of life is full of waiting. Waiting for parents to bring back food. Waiting to grow big and strong enough to wander the seas and fend for themselves. But lately, for growing numbers of chicks, those moments never arrive.
You see skeletons, and in the middle of the chick, their stomach is full of all sorts of plastic. The first thing you think of is, there's no food in here. There's no room for food. If their stomach is full of plastic, then it's displacing water, so they might be dying of dehydration. Or it's just malnutrition. It's just simply that they can't get enough food and nutrients. What is shocking to me is what these chicks have in their stomach is not from one feeding. It's from multiple feedings. So these very experienced albatross parents, they can live 60 years plus, are repeatedly recognizing plastic as a source of food.
Of course, plastic trash is abundant in their world.
When you look at some of these remote island shores just littered in plastics, and then when you see a chick dead with the belly full of plastic, it seems to make sense, but the mystery is that these birds don't feed on the island.
So where is all this plastic coming from? It's exactly that question that Charles Moore was prompted to ask on a voyage across the Pacific. The journey changed his life.
We had plenty of stores on board, plenty of fuel, and we decided to take a shortcut that most sailboats avoid. It took us a week to cross that area. And during the voyage, I came out on deck on a regular basis, surveyed the horizon, and was surprised that every time I saw trash.
Almost all of it is plastic.
I would bet myself, well, this time I'm going to go out on deck and not be able to see anything. But I would always lose the bet.
Halfway between Hawaii and the mainland, Moore had motored into the middle of a twice Texas-sized collection zone for floating debris.
Circulating winds draw the debris from around the Pacific Rim, and they bring it into the center, so you get a toilet bowl effect, but there's no exit. The material there may be there since the dawn of the plastic era. This gyre is an enormous area, and if that's as contaminated as the part that I crossed, then we've got a huge problem.
After consulting with scientists, he returns to measure systematically the volume of plastic in this stretch of ocean.
Okay, it feels like it's coming, yeah.
He's in for a surprise.
I thought what I'd be catching was toothbrushes and bottle caps. And it turned out that wasn't the story.
Moore drags through the sea a fine mesh trawl net, the kind scientists use to collect plankton.
Ready? Yeah. Okay, here we go. Very good. Looking good. And when we deployed that net and retrieved it and saw the soup of plastic that was in there, it was a complete shock. Turned out there was less plankton than plastic. Not only was the weight of the plastic greater than the weight of the plankton, but in some cases, the number of plastic pieces was greater than the number of plankton. I think it energized everybody on board, realizing that the ocean had become a plastic soup. Plastic polymers do not biodegrade. These pieces never go away.
And now that's part of the discussion, is how wide-scale is this pollution problem and how extensive is it in the ecosystem beyond the albatross chicks.
Because, of course, albatross aren't the only creatures out there looking for food.
There's definitely going to be consequences on many, many levels and for many, many species and in many, many habitats.
Each of us now produce more than 1,500 pounds of trash a year, and the fraction that's plastic is going nowhere but up. Dealing with all that trash must be getting harder, because every year more of it seems to slip through the cracks. When it does, it stands a good chance of making its way to a storm drain or river, and then on to the sea.
You know, a single serving throwaway container is the bane of the marine environment. Here we've invented a material that, for all practical purposes, lasts forever. And instead of using it on products that we want to last a long, long time, we're using it on products that we may only use for seconds.
Coral reefs all over the world are in retreat. Some are disappearing faster than rainforests are, leaving behind only bleached skeletons. Corals can recover from a little bleaching, but beyond a certain point, the process snowballs and their chances of survival plummet. But bleaching isn't the only threat to corals that's posed by the rise of heat-trapping gases in the atmosphere. Nearly half of the carbon dioxide added to the atmosphere in the past 200 years has ended up in the ocean. Here, it triggers chemical reactions that we don't notice, but other creatures do. The carbon dioxide is changing the chemistry of seawater, making it more acidic. Oceanographers call the problem ocean acidification. For countless sea creatures, from microscopic plankton to coral polyps, and perhaps even lobsters and crabs, building and maintaining a shell or skeleton is getting harder all the time. This is a coccolithophore, a single-celled marine algae that surrounds itself with calcite scales. And this is a coccolithophore on acid, or at least in more acidic seawater. Consumed by many zooplankton and even some small fish, coccolithophores are one of many increasingly vulnerable species at the foundation of the marine food web. If they're harmed by more acidic seawater, that ripple may be felt all over the globe.